You may have noticed on the term sheet these 4 words in a row that begin with the prefix iso. Iso, out of Greek, means line. An isopleth is a generic term. It's any line on a map that connects points of equal value. It makes no difference what kind of line it is or what kind of map it is. All lines on maps that are connecting equal value are generically known as an isopleth. But there's more specificity. An isobar is a line on a map that connects points of equal air pressure. An isohyet, can you see that HY? That means water. An isohyet is a line on a map that connects points of equal precipitation. And an isotherm, can you guess that one? Good. Of course, it's written out there for you. It's lines that connect points of equal temperature on a map. Let's take a look. You're, of course, familiar with parallels and meridians, lines of latitude, lines of longitude. These are types of isopleths. Every parallel is connecting points of equal latitude, and every meridian is connecting points of equal longitude. Therefore, those are isopleths, types of isopleths. Here's a map that shows isobars. This is the United States. This is barometric pressure. Notice that L close to the center part of the country where Kansas City's at. Closely spaced isobars indicate rapid change. And in fact, closely spaced isopleths of any sort represent rapid change. Widely spaced isobars, and for that matter, widely spaced isopleths of any sort, indicate gradual change. If you take a look at where Kansas City's at, and then you start to head north of Kansas City into Iowa and Minnesota and South Dakota and North Dakota, you can see that the isobars are all spaced very closely together. That indicates rapid change. Technically, we would call this a steep or a strong pressure gradient, which indicates rapid change in pressure over distance. However, as you go towards the left of the map, towards the west, you can see that there's a steep or a strong pressure gradient, but by the time you get to central Wyoming and then head into Utah and Idaho and Nevada and then the west coast, you can see that the isobars are spreading out. Or if you head south of Kansas City towards Texas, the same thing is happening. When the isobars are spread far apart, that's indicating gradual change in air pressure over distance. We call this a weak or a shallow pressure gradient. This is an isohyetal map of Africa. Notice the center of the continent and compare it to the north. As you're probably aware, northern Africa is dominated by the Sahara. This is indicating precipitation in centimeters. Right in the middle of the map is where the Congo Basin is at. The Congo Basin is home to the world's second largest tropical rainforest, and of course, it's in the tropical zone that I spoke about before. As you go away from that, you can see that, once again, the isohyets are very close together, which indicates a rapid change in precipitation over distance, so that by the time you get into the Sahara, there's very little precipitation. The reason the northwest corner of Africa has more 100, 200, 400 centimeters of precipitation is because this is where the Atlas Mountains are at, and they catch a lot of precipitation. Notice as you head south out of Central Africa, down towards the southern part of Africa, once again, these isohyets are going to stretch out a little bit and there's less precipitation. Finally, let's look at these two isothermal maps. The first one is indicating January average temperatures. So first, notice all those temperatures, all those lines are isotherms. They're connecting points of equal temperature. Then notice, because this is January, that the center of heat, which is indicated by the reds and oranges, is in the southern hemisphere. You now know why that is. In January, the subsolar point is in the southern hemisphere. In fact, it just passed the Tropic of Capricorn at 23.5 degrees south. Wherever the subsolar point is, that's where the center of heat is at. And of course, in January, the center of heat on planet Earth is going to be in the southern hemisphere. Take a look at this isothermal map in July. Notice how it all shifts north. because the subsolar point shifts north. Do you see the utility of these types of maps? The isotherms are showing you what's happening with temperature.